Do you remember the electric eels that turned Max Dillon into Electro in The Amazing Spider-Man 2? Let's forget the superhero part for a moment, because there's some real science behind that scene. These animals can generate hundreds of volts, using powerful electrical discharges to hunt in the dark, murky waters of the Amazon. But what if we put that natural power to a completely different use? Could we use it to power an entire city? And how many eels would we need? Let's find out with What If Explained TV. To answer that, we first need to know how much electricity one electric eel can actually produce. Electric eels have specialized organs containing thousands of cells called electrocytes. Each cell produces only a tiny electrical potential, but when thousands of them work together, those small voltages add up. Large electric eels have been recorded producing around 600 volts, with currents reaching roughly 1 amp under certain conditions. For our calculation, we'll assume that pulse lasts about 1 millisecond. That gives us about 600 watts of power for that brief moment. But over just 1,000th of a second, that works out to only about 0.6 joules of energy. If we assume one eel produces one pulse like that every second, its average power output would be only about 0.6 watts. To put that into perspective, a 60-watt laptop would need around 100 electric eels. A PlayStation 5 using around 200 watts, while gaming would need more than 300. And a 1200-watt microwave would need about 2,000 electric eels. And those are just ordinary devices you might find in a home. Now let's scale this up to an entire city. Take Seattle as an example. A city at this scale can require roughly 1 gigawatt of average electrical power. That's 1 billion watts. If each eel gives us an average of 0.6 watts, dividing 1 billion by 0.6 gives us roughly 1.67 billion electric eels. To get some idea of how enormous that number is, Blue Ridge Aquaculture in Virginia, one of the largest indoor tilapia farms in the United States, can raise around 2 million fish at a time inside a facility covering roughly 100,000 square feet. And tilapia can be raised at very high densities. Electric eels are different. They're much larger, need more space, and of course they can discharge electricity. So with the number we just calculated, a few hundred facilities the size of Blue Ridge probably wouldn't be enough. We could be looking at thousands of enormous farming facilities. And even that is based on a very generous calculation. We're assuming every eel can produce the same strong pulse once every second, consistently. In reality, their electrical output varies depending on their condition and activity, and they also need energy and time to recover, so the actual number of eels could be even higher. But suppose we decide to build it anyway. Space is only the beginning. We still have to keep all of those eels alive and functioning. They need food, water, oxygen, and suitable living conditions. The system would also have to maintain water quality and deal with an enormous amount of waste. Even if we somehow built a farming system on that scale, keeping it running would require a constant supply of energy, resources, and money. Compared with a conventional power system, maintaining billions of living animals makes the whole process far more complicated and expensive. But the problem doesn't end there. We still have to actually collect the electricity. Whatever system we use would need to capture as much electrical energy as possible without harming the eels themselves. And because electric eels produce very short electrical pulses, that electricity would then need to be collected, converted, stabilized, and possibly stored before it could be sent into the grid. Every extra step makes the system more complicated and introduces additional energy losses. So the question, how many electric eels would it take to power a city, may have a mathematical answer. But in practice, turning billions of electric eels into a power plant simply wouldn't be efficient, either technologically or economically. So what do you think? What other ability found in nature sounds ridiculous at first, but might actually be worth trying to turn into technology? Let us know in the comments. And if there's another what-if question you'd like us to explore, leave that below too. It might just become our next video. And don't forget to like, share, and subscribe to What If Explained TV, where we put seemingly impossible ideas to the test with science and reality. Thanks for watching, and we'll see you in the next one.